Hi, in this presentation, I'm going to talk about our demo system that visualizes cross-lingual discourse relations in TED datasets. First, let's take a look at what discourse relations are by taking these two sentences as an example. If I say to you, I have cooked some pasta, I'm hungry, then you would probably infer that the second sentence, me being hungry, is the reason why I've cooked the pasta. So these two sentences are linked with a causal relation, and it is an implicit causation as there's no explicit discourse connectives such as because. Here are the same sentences translated in Korean. Similar to the English case, we also don't have an explicit discourse connective linking the two sentences. However, Korean is an agglutinative language where complex meanings are formed by attaching affixes to word stems. In this example, the two red characters are postposition that explicitly reveals a causal relation. So we can see that although these English and Korean sentences talk about the same thing, the grammar of one language can affect the discourse relation. It would be interesting to see if there's any cross-lingual patterns across multiple languages, as these kinds of information can be useful for machine translation, especially at document level. So given human annotated cross-lingual discourse datasets, the objective of our demo system are: we'd like our system to compute and display overall patterns of cross-lingual discourse relations, draw graph networks that illustrates the cross-lingual relations between pairs of languages for closer inspection, and to provide a general search function to look for specific sentences in the datasets. Fortunately, there are already some human-labeled discourse annotations. The first one is TED-MDB, that provides 6 cross-lingual TED Talks that are for 7 different languages. And we also have a similar dataset for Chinese, covering 16 TED Talks, where 4 talks are overlapped with the TED-MDB. So in total, we have 4 talks covering 8 languages, and 2 additional talks that cover 7 languages. And these talks are annotated following the Penn Discourse Tree Bank framework. In order to use these datasets in our system, we performed the following pre-processing steps. First, we segmented the raw document-level texts into sentences and adjusted the annotations accordingly. Then we automatically matched the English sentences from the English talks with sentences from other languages by employing sentence similarity measures. For example, the cosine distances between sentence embeddings and character F scores between English sentences and English translations. The table on the right shows an example of pairwise sentence matching for a TED Talk. Then we manually went through the matched results and revised them if needed, and these English-based alignments were used as a pivot to compute the alignments between non-English languages. So in the end, our combined dataset has the following statistics shown by the table on the left. And we also like to point out that in our analysis, we considered the level 1 and 2 discourse relations from the Penn Discourse Tree Bank framework. The codes and the process dataset are available at the GitHub repository, and the running demo can be accessed online as well at this link. So let's briefly browse through the demo system. On the left, we have a navigation panel showing 3 pages: overall patterns, pairwise talks, and search. On the top of the overall patterns page, we have a heat map showing the preservation of discourse relations across all language pairs. For each language pair, we have 3 cells. From left to right, they show matching discourse relation at relation type, level 1 sentences, and level 1 and 2 senses. We can observe that the relation types and the level 1 senses are quite well matched across the language pairs. For the next section, we can select 2 languages and look at the patterns in more details. For example, by applying association rule mining, we can see if there exists any interesting rule for each discourse level. We note that while most of the rules learned are identity rules, meaning that the same discourse relations are likely to occur cross-lingually, there are some cases where the relations are different. For instance, we learned that the level 1 sense, contingency for Russian, co-occurs well with expansion for English. At the bottom of the page, we see pie charts that are drawn for each relation level. This provides more detail on the proportion of the preservation of discourse relations. Next up is the pairwise talks page, where an interactive graph network is drawn for a pair of languages for a specific talk. A node in the graph represents a sentence, and an edge between nodes depicts an intersentential discourse relation, while the vertical lines indicate cross-lingual alignments. The graph can be zoomed in and zoomed out, and when clicked on a node, we can see its corresponding sentence with intrasentential discourse relations marked as spans of tags. Last page is the search page, where we can search and retrieve specific nodes based on keywords. In order to provide more context, the search results also return the neighboring nodes as well. Thank you for listening, and I hope to see you all in the workshop.